In this clip from RMDS Lab's I'm Data conference, you'll hear from Matthew Schneider, Assistant Professor of Statistics and Data Privacy at Drexel University. Matthew will speak regarding data privacy of user-generated content, specifically textual data.
Hi, good morning, good evening, good afternoon, wherever you are. My name is Matthew Schneider. I'm a professor of statistics and data privacy at Drexel University in Philadelphia, Pennsylvania. This is joint work with Sean Mancat at Cornell University. Today, I'm going to talk to you about the data privacy of user-generated content, specifically online reviews, but I'm also going to show some other applications like AI chatbots, emails, tweets, student essays. And really, this is about the privacy of textual data. So if you're concerned about protecting your textual data with GDPR or CCPA, this will be pretty relevant. So, in terms of online reviews, lately, there have been a lot of lawsuits where people have been identified on Yelp or other platforms based upon what they wrote in the text or their writing style. And you can see here, there's just a bunch of negative news articles on people being identified from textual data. So this is an increasing business. And in particular, I'm going to show you results from a de-anonymization methodology that I've created here to see how identifiable people are based upon their writing style in online reviews. So privacy is an emerging issue for review platforms. Anonymity is at the heart of many systems. So you can think about in academia, teaching evaluations, they want students to be truthful. Employee or consumer surveys, a lot of these are released and people can be identified along with their sensitive information. And also chatbots. I guess we'd be hard pressed to find a data protection strategy where you could actually share that chatbot textual data and all of that text data is actually private and nobody's identified within it because they can write whatever they want in them, right? So if reviewers can be identified, they may stop leaving critical content. This, of course, is going to depend upon the brand positioning of each platform, and readership can also drop. So I'm going to lead you through a very specific problem setup that I have here. And I'll leave some room for questions at the end if we have any time. But essentially, we have a set of reviews on platform A. So you can think about a Yelp or an Amazon where authorship is known. And then a new review comes through on platform B, right? And platform B, it might also just be a different review under a different account name. So platform A asks, who wrote the anonymous review? And why is the review attributed to author I? Platform B may ask, what can be done to protect anonymity? And how would protection impact content quality to the general public? Okay, so the de-anonymization method of who wrote the anonymous review. So here's an example. This is a review on Yelp, right? And I just want you to look at it and see the information that's available. So you can see essentially there's structured data, which is the first name Alan, the last initial K. You can see a location, San Diego, California. You can see a date of the review. So if somebody got this negative review for their business, they might be able to look at their customer database and figure out who it is based upon this structured data alone. So the first stage of our de-anonymization algorithm uses the structured data to narrow down a list of potential authors. So we might have, hey, 10 authors fit this criteria of Alan in San Diego around this date. And the second stage is using all of that textual information to further identify who that exact person is. And you can see the writing style here. It's different for different people. There are spaces between paragraphs. Alan prefers to write in like a list format. He puts the first, the second, he uses colons a lot. So we use exact matching of the structured data to identify a set of potential authors. I have other papers which relaxes that. So this could be relaxed for fuzzy matching, cosine distances, right? To where instead of somebody just in San Diego, maybe Los Angeles could be included as well. And why is it so difficult to figure out who's the author based upon text? Well, reviews can have a varying number of words. So you don't always want to predict the person who writes the most because they're going to have the most amount of textual variables or features in their writing. Sometimes words matter, but sometimes they don't. On top of this, people can write ungrammatically, misspell words, run words together, and all these weird things that people do as a part of their writing style. The typical solution is to pre-process this data and remove all of those. But that's exactly what we don't want to do, because when we're trying to forensically analyze who wrote something, these are often the most predictable, right? If somebody misspells a word a certain way, odds are not many other people are going to make that same mistake. And those are the things that are most predictable, all right? So that's the second stage. Now here I just have a relatively simple list. This can be expanded, and I have expanded it before. But we look at textual features such as number of colons, number of semicolons, spaces. We even have some interesting things like the Flesch-Kincaid reading level, which looks at the average length of the sentences compared to the average length of the words within a sentence, right? And this was used in World War II to essentially figure out who would be an officer, who would be enlisted, just based upon their writing sample, all right? And also we have every English word in the dictionary, as well as two-word phrases and so on, okay? The typical classifiers when we have a lot of training data, which in this particular example, at least for Yelp and Amazon, we do have a lot of training data. We would just use support vector machines, classification trees, random forests, and so on. So a lot of you are already familiar with these. When you don't have a lot of training data, there's other papers that I'm writing which will adjust some of these, okay, to unsupervised learning. Now, just to review random forest, essentially what we're doing is we're taking a random subset of all textual features, right? We're fitting the best possible tree to it. And so the nodes at the end are essentially predicting what author is which based upon which textual features are in the document, right? We're doing a whole lot of those trees and we're averaging over the results so that we can get a probability for a sample document or an online review that we see online that each specific author wrote it in our database, okay? Now I'm going to go through some of the results. So for Yelp, we have over 1 million authors. We have over 5 million reviews. So this is essentially using almost everybody. Structured data variables are first name, last name, and product. For Amazon, we just took the top 200 authors, so the most frequent authors. They've produced over 60,000 reviews, and this is important because you might have frequent authors that are paid or writing fake reviews, and then they'll create a new account, right? And Amazon might want to track them across accounts to figure out, you know, who's writing all these fake reviews. They might want to remove them from the platform and so on, or maybe they don't. We construct a hypothetical target review, then count the number of other reviewers that match the structured data of the hypothetical target review. So for example, how many Allens are there in San Diego, California, right? Then we vary the structured data associated with the target review. And what you see here, there are 1.32 million reviewers on the Yelp data set that we have. Okay, so if you were to get a writing sample of a target review that came across for your business, you're trying to figure out who wrote it, it would be 1 out of 1.32 million, right? Really hard to figure out who wrote it. But when you look at first name, there's one first name, John, which essentially has 12,000 reviewers, over 12,000. But importantly, over half of the first names, they're completely unique, right? So somebody is identifiable based upon just first name only in over half of the reviewers, right? Which was kind of surprising. And then when you go to first name plus last name, it gets a little bit worse as expected. And finally, when you go to adding the business name in there as well, you can see that for 99% of the unique combinations of first name, last name, and the business or service purchased, right, there's essentially 4 potential authors or less. All right, so the basket is really small. So if we have 4 authors, we're just trying to figure out which one of those 4 wrote a target review based upon their textual writing. Amazon is pretty similar, although there's only 200 reviewers that we analyzed, right? But in general, some of the structured variables are a little bit different. The results are fairly similar. This is structured data only, stage 1. So the experimental setup.
If you enjoyed this video, check out the extended full talk on grmds.org. Use the link in the description to take advantage of a complimentary 1-month premium membership to our data science ecosystem where you can access online courses, webinars, datasets, workflow collections, and much more. Be sure to like and subscribe if you enjoyed this video for more content like this.